Hello, and welcome to the Data Platform Summit 2020. This is a virtual event. I'm recording this session right now in beautiful, snowy New England, and I'm looking forward to taking part with you guys in a virtual fashion at the same time as I'm presenting to you now. So let's go ahead and get started. My name is Grant Fritchey. I work for Redgate Software. I've been doing this kind of deployment stuff with databases in an automated fashion for more than 15 years. So I've got a lot of experience with it. I am a Microsoft Data Platform MVP, and I am an AWS community builder. You've got my contact information here on the screen right now. If you want to get in touch with me to ask me questions after today, I encourage you to please use this stuff. I've been doing this for a long time. I really enjoy it, and I mostly enjoy sharing it with others. So please take advantage of this contact information. Please use it and get in touch with me if you have questions after today, because I'd like to try to help out. Now, our processes today are pretty simple. What we're going to be talking about is DevOps. And we'll talk about it some. We'll get to it. But I want to talk about DevOps. I want to talk about what DevOps is and how DevOps relates to databases. I really want to get into that and get some, baselining and some understanding of why I'm encouraging you to do DevOps style automated deployments. You don't have to do full-blown DevOps necessarily, but there's a lot of benefit to automating how you're doing your deployments. And so we're going to talk about that. Specifically, we're going to be talking about the tools that would allow you to use AWS to do this. We're going to show how to set up a full CI process. We're going to show how to set up maybe a QA process. We're also going to show up how to set up an approval process and then get your code out into a production server. I'm going to walk you through all the way, and we're going to have a whole bunch of different things. And this is just one possible path the code could take. Once you start to build these and you understand how you can control your databases through these processes, there's all kinds of different things you could do. So I'm going to show you one set of examples, but it's not the only way you could get these things done. There's a whole bunch of other stuff that you could bring into this. Okay, so let's talk about what I mean when I say DevOps. DevOps in and of itself is an agile culture that better supports collaboration between people using automation and tooling in support of process. But the key here is that it's all about the people. It's all about that collaboration, the communication between people. I try to keep these definitions as simple as I can because DevOps can seem extremely complicated. DevOps style approaches to your deployments, to your development, can seem very complex. And there are a lot of moving parts. As we go through the tools today, you're going to see that there are a lot of moving parts. A lot of different things are engaged with the process. But the goals of it are simple. People and collaboration. That's it. That's all it's asking for is people and collaboration. But there are some fundamentals to arrive at that place. So let's talk about those fundamentals. The first thing is communication is everything. There's nothing that you're going to be doing if you're going to take on a DevOps style approach that doesn't involve communication. It is fundamental to everything you do. It's fundamental to the entire approach. And you cannot escape the concept that you are supposed to be communicating. And the entire purpose of setting up some kind of DevOps style deployment mechanism and testing mechanism and all the rest is all about ensuring that you've got better communication across your teams, between your teams, within your teams. It's all communication. So we focus there, we focus on that first. That's just absolutely fundamental to what it is. In order to make this work, the next thing we have to focus on is source control. All of our code should go into source control. Application code lives in source control and has for the last 30 plus years, more than that even. Database code needs to go there too. Now, I've seen surveys from my company and from others, and only slightly more than half of you have some of your database code in source control. Probably not even all of your database code in source control. So a majority of people are not treating their databases as code, and fundamentally they are. Source control has a whole bunch of benefits we'll get to in a second, specifically for the database. But at the core of it, the whole idea of source control is to have a known state, a managed state, and a place to communicate. Source control acts as a communication mechanism. As you check things into your source control system, as you add things to them, you put in comments so people know why something was added. They understand better why things are included. And so source control becomes a major part of the beginnings of your DevOps journey if you're going to follow one. But even if you're just going to try to automate a few of your deployments to make them more efficient, to eliminate friction, to add some value to what you do, that's all great, right? That's all good. But source control is going to be one of your starting points, so you need to make sure that you're doing that. Now, the next thing we need to do from a DevOps style approach is we've got to talk about shift left. Now, shift left is, the concept is simple. You've got a pipeline, right, that your code starts in development, it goes through a testing process, it ends up on production. Maybe more complicated than that, certainly, but we'll just go with that. The idea being that starting point on the left, on the far side, that starting point is dev. And you want to make your dev environments look as much as you can, and I really emphasize those words, as much as you can, you want it to look like production. Now, it's not going to be production. Because of privacy and protection laws, you can't have production data in non-production environments. So, that's one reason why it's not going to be an exact match on production. But you're going to try to make it as close as possible to production. And the reason for this is very, very simple. The closer your development looks like production, the closer your QA system looks like production, the closer any kind of pre-production systems look like your production environment, the more you're going to be testing your software before you get to production. The more you shift left, the more you take what is production and move it into your non-production environments as much as you can. Again, I get it. You've got a 50 terabyte database. You can't have 6 copies of it laying around. Understood. But as close as you can, you need to move stuff, do the shift left, because it adds a whole bunch of protection to your production environment. Next up, you're going to automate testing. Now, we're going to talk specifically about databases and testing automation here in a minute, but the general idea is very simple. As you start to do things, you need to test them. If you're testing them manually, that's a lot of work on your end, and frankly, you can mess stuff up. So if we automate our tests, that means they're repeatable, they can be rerun over and over again. If we're missing a test, it's easy to add one. If a test is no longer applicable, it's easy to take it away. Or if tests are failing, it's easy to go in there and figure out why, and if it's something wrong with the code, cool, we caught it. Or if it's something wrong with the test, we can fix it. And so we're ensuring that we've got the kinds of protection in place that we need. And that's what it's all about in doing automated testing. Now, next, after we've done all the rest of this work, we're going to set up automated deployments. We're going to figure out how to get our code out of source control and move it between our environments. Deploy it to dev, deploy it to a continuous integration environment, deploy it to QA, whatever. We're going to figure out mechanisms for making this automation occur so that we take as many manual processes out of the entire thing that we do. Now, why are we removing manual processes? Well, you don't want me, and I'm just picking on myself here. I'm not picking on you guys at all. You don't want me doing your deployments because I have a tendency to mistype things. I will mess up. So I will skip steps. I will forget about things. So the best thing you can do with me is say, Grant, go automate this. Because yes, I'll mess up while I'm automating it, but I will fix that over time. And eventually we will have an automated deployment that's consistent and works the same way every time. And that's what we're going for, is this consistency in methodology, because it allows us to then do all the rest of the fun stuff, but do it in an automated way so it gets faster and easier. And that's all curling back around to the idea of DevOps, tools and automation in support of process. Finally, as part of DevOps, believe it or not, we want to monitor our servers. Now, there's a couple of things we're going to monitor for. One, we're going to monitor for behaviors, of course, because we want to know when we do a deployment, did it improve things or did it make things worse? If it improved things, great, win. If it made things worse, okay, we're going to have to do some more work and fix it. But also, we want to monitor for our actual deployment processes. If we're automating these, and the more we automate them, we may even automate them all the way into production, we need to be able to monitor when they ran. So we know when the changes occurred. So if something does blow up, we know that a deployment occurred, and so we're able to track that down. So the monitoring is a fundamental part of DevOps. Also, monitoring acts as an innovation platform. We know that something is running slow. There's our target for the next sprint to try to build something faster. Let's work on it. So monitoring acts as that mechanism. And so these are the fundamentals of DevOps. This is the stuff we need to do. We've got to set it up this way. We've got to concentrate on communication, right? The elimination of the elimination of silos, the elimination of walls. We've got to tear some of that stuff down. That doesn't change anyone's responsibilities fundamentally. Developers don't suddenly get SA privileges in production under DevOps. That's not how it works. It's just not. We're going to be automating our processes in such a way that so that developers don't need SA privileges in production. If they have a change they want to get out there, we've got a process in place. It's automated, it's tested, it's approved, and hey, look, they can get out to production that way. Cool. That's the whole idea there. It's very simple. But if you're a DBA type, you're still going to be responsible for backups. You're still going to be responsible for index tuning or statistics maintenance or whatever. None of that's going to change. But what it is that the changes that are fundamental to the business are going to be following these processes so that we're no longer doing things manually and frankly messing it up. So let's talk about DevOps and databases. Because the thing is DevOps actually has a unique set of benefits for a database. First up, if we start breaking things down, so we're eliminating these silos, it's no longer going to be the development team and the DBA team, and no one gets along and everyone's angry with everyone. We're talking to each other. We're one team. We're taking on the idea that we are responsible for the application. Yes, my specialty is data management. I'm going to be focused there. I'm going to be ensuring that we've got good query tuning. I'm going to be ensuring that we've got good queries. We're going to be going through that work as needed. That's fundamental to what we do, no questions asked. But we're going to be doing it as a team. I'm going to be moving fast with you as the developer. I'm going to be mirroring a lot of your methodologies. Heck, I'm going to be using your language. Next, we have to talk about source control. The whole idea here of source control is for a database. Yes, we need to have that same thing that code needs. We need to have that known state. We need to be able to track the changes, who made what change, who introduced what change. The auditing of within source control is amazing. So it's a great thing. We know who made what change. But the real thing for source control from a database standpoint is source control acts as another backup. It's an added backup. So we've got more backups, better backups, added backups. And added backups means the ability to undo things, track who made what changes. It's just a great way to go. So it has a real benefit for the database itself. Next, the shift left, as I already said, it adds protections because the more we are testing in a production like, or as close as we can, environment, the more we are catching problems early. We're not only looking at them in prod. Developing straight to prod, people do it, I get it, people do it, but it can cause all sorts of problems. You can get outages and data loss and who knows what else. I've seen horrible things. But we're not going to talk about horrible things today. We're talking about good things today. And the whole idea here is that it does add protection. Automated testing is automating that protection, is ensuring that the protection that we're doing isn't simply, well, we ran a test, it's all good, but we're automating it so we can run them again and again and again. Every time they fail, we go out and try to fix something. If it didn't succeed, the test will fail. We will figure that out quickly and go back in and try to fix it. It adds protection to our production environment. And if it sounds like I'm saying the words protection a lot, I am, because DevOps is not simply a way to move faster. It is. It's very much a way to move faster. Automation, collaboration, communication ensure that we are moving faster. But they all also add protection for our production environments. And to me, as a paranoid control freak, also known as a DBA, that added protection is the big deal. So for example, the more deployments we do, meaning I make a code change, it goes through a continuous integration process, which we're going to demo here today. Cool, that's a test. Did we pass or fail? We failed. Oh, okay, well, let's go figure out why. We passed, the code succeeded. Yay, we win, cool, off we go. And keep going, you know what I mean? And over again, we do that. And that's a test, and we passed it. Then it deploys to the QA environment. Cool, did that deploy succeed? Yes, another test. Win. More protection for our production environment, but also simply practice. We're practicing deployments. We deploy to a pre-production environment. Did that succeed? Yes. Awesome. We're really getting good at these deployment things. Let's go to production with it because we've tested the same script all the way. We know it's going to work. We get to production, and sure enough, it works. So we're good. Now you'll notice monitoring. I didn't add anything to the monitoring thing from the last slide, and that's because the monitoring doesn't really change for databases. It's the same concepts. It's the same benefits. And so you want to make sure that you're monitoring your databases too as part of your DevOps process. It really is. Okay, so that is all of the DevOps fundamentals. Now I'm right here with you guys live. So, I'm recording this, but I'm live online with you. If you've got questions about what DevOps is and all that fun stuff, go ahead and type them in. I will try to answer them the best I can there with you. But we're going to move on and start talking about specifically the Amazon Web Service developer tools. Now, the AWS developer tools are pretty cool. There's 4 of them. They're really straightforward. They do exactly the stuff that you want. But the interesting thing is how complex they can be. But they don't have to be complex. So we're going to drill down on that and go over it. Now, the 4 tools are Code Commit, Code Pipeline, Code Build, and Code Deploy. So let's walk through them. And they're all part of AWS. Now, Code Commit is their source control. And it is fundamental to everything you do. You've got to have your stuff in source control. Now, AWS will support all kinds of different source control systems. You could use GitHub, you can use others, but they've got their own Git implementation, which is Code Commit. And it is the starting point for everything that we do. So it is source control, it's versioned, it's branched, it's everything that is Git. If there's a session in 2020 here, in the DPS 2020 for Git, I really strongly recommend you watch it. I haven't looked at the schedule to see if there is one, But if there is, it's great. If not, I know that Kendra Little has a session on it that you might track down, and Steve Jones also has a session on it you might track down. They do a lot of stuff talking about Git for DBAs, so it's a good way to get started. Git is getting started, haha. Anyway, Code Commit, great tool. We're gonna look at it here in a little bit, but it is fundamental to the thing because you've got to have your stuff in source control in order to automate it, and so that's step one. Oh crud, I forgot about that. So step two is the code pipeline. Now the code pipeline is what controls what happens. It will have a set of triggers. Now the triggers could be anything. In my case, in the demo we're going to do today, when the code goes into the source control system, code commit, that acts as a trigger. But you could set up triggers to be schedules, say, for example, oh, we deploy every day at noon, or 3 o'clock or something, or we deploy on demand. Clicking a button could be a trigger. In fact, I can show you when we go to the demos exactly how you could fire off your own deploy right through the interface, and off you go. So you can click on it. But the whole idea of the flow control is it's literally what it says, a flow control. Do this first. If it succeeds, do this next. If that succeeds, do this. If any of them fail, send an email. Let us know that something failed. Ta-da! I mean, there is a flow control process. You can even have it, one of the actions can be an approval process. We're going to show that in the demo today too. And that approval process is built right into the pipeline, and it's going to show you, how the system is behaving there. And this is, if you're going to set up continuous integration, you've got to have a flow control system, in this case, code pipeline, but there are other ones as well. And we're actually I'm going to show you a little bit, but only a little bit, of another flow control system that's available to us through AWS. Now, next up is code build. Now, code build is commands. And what the commands in this case are is a virtual machine. It's setting up a virtual machine. That's the first thing it's doing. And then the next thing it's doing is it's taking control of that virtual machine to then use it as computing power to do something. Now, what is it doing? In a lot of cases, what it's doing is it's compiling all of your code into an executable, into a DLL, into a web page, or in our case, into changes it to your database. Frankly, SQL. But the whole idea here is it controls what happens. Now, it uses a YAML file. The YAML file is really straightforward. It can be insanely complex if you let it, but you'll see in the demos it can also be very simple. So there's not really any kind of panic here. We can make it be what we need it to be. It's just command line arguments. So one, make sure you're learning command line arguments, and two, you've got a lot of control as to what it's going to do and how it's going to do it. A lot of the ways that I'm running it is I run it within Ubuntu, so it's all Linux, and so I'm using Bash scripts. Occasionally you can run it as Python. I mean, it's all on you how you want to make the calls. Also, the other thing I'm doing is I'm using Docker containers actually for my command line calls. So I can go and get the container I want. It's going to do things, and I control it all through the command line. So one of these things that you will need to do as a DBA is start expanding past the database. Start learning how to do some of these automations and some of these scripting languages so that you can take control of this stuff and make it happen. And then finally, code build it doesn't have to, but it can build artifacts. We're going to show a demo today where it does. An artifact is, like I said already, a DLL, an executable, or in our case, an SQL file. Because I've got a paranoid path. I'll explain it when we get to it, but I've got a path where I slow things down so that I can control exactly what happens. So we'll see that in the demo. The next thing you want is code deploy. Now, code deploy is a consumer of the artifacts that code build generates. Code deploy, interestingly enough, is completely optional within the pipelines. You can do a lot of stuff with code build only, and I will demo exactly that. So there's a lot of things you could do without ever generating artifacts. But when you have to start moving stuff around to different applications, to different servers, and most importantly, when you need to use this stuff that's all up in the cloud to get it down to your local servers, code deploy is your friend. Code deploy is the tool that's going to make that happen. And we'll walk through exactly how that works too. So next we have to talk about dealing with data. Now the thing is that it's easy to talk about, oh, we'll put everything in source control and then automate the deployment. The problem we have is that databases don't deploy the same way as application code. And the reason for this is simply data. The data is different. Now, data is different because data has to persist. An executable, we can compile an executable, throw the old one away, put the new one in its place, yay, we win. Data cannot be thrown away. It has to be maintained. So there are a lot of tools out there for dealing with data. These various tools work in different ways. Some are better than others, but the whole concept is simple. All the tools I've got listed here go into the data, into source control, get your code, and through one mechanism or another, they deploy your code. Now, the two mechanisms you're most likely to see are what are called state-based or migrations. Also, migrations is sometimes called a manifest. The concept is really easy for state-based. Compare two things. Find the differences, generate a SQL script to make the changes occur. Now, these different tools, some of them work with different databases, some of them work with only one database. So for example, the Idera DB Change Manager works with SQL Server. It's a state-based tool. It makes the comparison between two states, say source control and a database, and generates a script between the two. Now, DBUp is an open source tool, and it covers more platforms. It covers quite a few different databases. It uses a migrations approach or a manifest, which is a list of changes, and it will run them in a particular order, and that's what it does. It doesn't do comparisons to arrive at that. It just runs that manifest. Now, SQL Server database tools from Microsoft, also known as SSDT, that's also a state-based tool. It only works with SQL Server, but it works that same idea. Stuff in source control, compare it, generate the changes, and then what it spits out is what's called a DAC pack. And the DAC pack is basically just a way to identify those changes that have been done. It does the comparisons to make the deploy happen, and that's how it works. It is not a manifest tool. It is absolutely a comparison tool. Regate Deploy, that one is a hybrid tool. It does a little bit of both. So it does some migrations, and it says it does some comparisons, and you can kind of configure it the way you need to make it work both ways. Datical, that one is a by the way, Regate Deploy is multi-platform. Right now it's SQL Server and Oracle, but there are others. Datical is multi-platform, and it will run a manifest as well. Flyway, open source, supports 20-something different database systems, and it uses a manifest as well. Flyway is what we'll be demoing today. It works really well in containers, and we're working with a Postgres database today to show off stuff other than SQL Server. And then DB Maestro, again, another comparison tool to arrive at the comparison choices. And these are the different tools. The whole idea is the compare has some advantages. It's really easy to understand. You make the comparisons, you generate the scripts. But some scripts can't be generated from a comparison tool. And so you have to get into manual intervention. So that becomes very much a problem because you don't want to do that. The migrations approach fixes that problem. And that's one of the biggest the greatest things about the migrations approach is it fixes that whole manual intervention thing, because the migrations is simply, hey, give me a script, tell me what order it has to be in, and I'll run it. And so if you've got a particular script you want to run a particular way at a particular point in your process, you put it in that right point and ta-da, it goes. It's that simple. The issue you run into with the migrations approach is it doesn't work real well with branching code. There's a lot of issues with branching code and the migrations. So if two people are setting up migrations, there's going to have to be a lot of coordination so they put them into the same order, because if I put it in one order and you put it in another and then we try to merge, we are going to have conflict. So that's what happens there. But these are the tools that we need to do, because we have to deal with data. We can't get away from the idea of data. So we're going to need to use one of these tools to deal with that. So with that, let's go ahead and switch over and do a demo, and we're going to walk through all the AWS tools that we covered and show you how they work. All right, for our demos, we're going to start off here in Azure Data Studio, and I use that just because I like its connection to Postgres, so it makes things easy, and it works directly with Git. So again, making things more easy for me. Now, what we're going to do is I've got a view. I want to create a view, a new view for my code, and I'm going to put that view into my code, into my databases, and get it deployed out through my systems. So the idea is pretty simple. Create a view, define the select statement, and I've already tested it, so I know that it runs. So what we need to do now is get it into source control. That's our only goal here, nice and simple today, is get it into source control. So let's go take a look at the changes we have. You can see that I've made the change, but I've not yet staged the change. So we're going to go ahead and stage the change up into my source control. And I've done some other work as well. And we're just going to make sure that we put a comment in. And what we're doing is adding a new view for inventory. So it's the inventory view is getting added to the system, and we can now commit that. Oops, forgot to save it. There we go. And so we've saved it and committed it, and now that's in my local Git repository. Now I can keep working, pulling stuff out of Git, make changes, putting stuff back into Git over and over again, accumulating the changes and getting work done. But for demo purposes, we're just going to do this one thing and then move on. So what we've got now is this file that we've created that is my view definition. Cool. Let's go ahead and push my changes from my local Git repository up to the cloud, up to Amazon. So we're going to do the push process. Now that's taking care of that. There's really almost nothing I have to do here. It's going to push it up, and that's all done. So let's switch over to take a look at the AWS console. Now this is the AWS console, and we're starting off right here with my code repository. It's called Ham Shack Radio, and it's for the Ham Shack Radio database. And so we can click on that and open it up, and it's going to show us files, because it is simply a file repository. It's just a file repository with versions and comments and all that fun stuff. So branches and all the rest. So if we take a look, we can open up SQL. It's going to load up, and we already see the inventory view that we created. There is our view, all defined, ready to go. It's done. It's up in source control. So there's our first step. We're able to put code into source control. Code commit, you can look at pull requests and manage them from here. You can definitely take a look at the commits that have been occurring, and you should see a few that have happened, including the one that we just did a minute ago, and then a whole bunch I've done several days ago, and then some other stuff I did days before that where I was working, on different things to get stuff done. You can take a look at the branches. Right now I'm working off of a single branch. If you're a Git expert, you're probably cringing right now. That's okay. This is demos only. So I'm just working off the one branch. And you can get into Git tags. This is a full Git management system. Yay. Cool. That's not the exciting bit. That's our foundation. That's how it's getting us started. In the background, behind the scenes, this is my ham shack radio pipeline. And if we take a look at it, it's actually running right now. And the stuff that I've got in there is going. It has already recognized that I've added something to source control, and it's now pulled that out of source control. Cool. It then has done a build. So it's done a build step. It is actively doing a QA process. Next, it's going to hit a production approval process, and then it's going to go to production deployment. So this process that I have set up, and this is just an example process. You can set up a whole bunch of different processes. You can have one process feed into another process. You can set up stacks of pipelines that feed into one another. You can combine them with code. You can, the sky's the limit. It's just kind of like use your imagination to support your process the best way you can. What I'm doing is really simple. The first two steps that, and you notice, if you notice down at the bottom of the screen, the green one's already succeeded. The second step has already succeeded. And so it's probably going to be waiting for a production review and approval. We'll get to all that in a little bit. My first two steps are the core that I want you to take away. Source control, which we've already looked at, and that's managed. You can manage it locally and on the cloud, both. And the initial build. Those are the main two things in my pipeline. Now, if we click on Edit Pipeline, we can go in here and start making manipulations. And you can edit each stage. So we can pick and choose how we want it to do, what source we want it to do. We can add additional actions in each step. There's a whole slew of stuff we can do. It's just a question of defining your own environment and what each thing is. I've broken it out into individual steps. 1, it makes it easy to manage. 2, it makes it easy to report on. 3, it makes it very easy to demo. But it is one approach. You could stack them within groups. It's all a question of how you want to manage your own system. If you're getting into security settings, it could behoove you to put a lot of work into one stack and then from there have a second stack with a different security setting, and you just either pass parameters between the two or put stuff out to, say, S3 storage or someplace else, and then pull it back in. Again, the options we have here are almost limitless, but I'm just keeping a really simple one where I've got my source control, and then I'm doing a nice simple build for my continuous integration step. My next step in my pipeline, right? We're only talking about the pipeline at the moment. Assuming my continuous integration build succeeds, I then do a QA deployment and artifact creation. So I do two things in this step. It is still a build step. It's just I've named it, whereas this one I didn't name it, this one I did. Again, I just want to illustrate the things that you can do. There's nothing in here of what you have to do. Each of these things is optional. You don't have to have multiple build steps. You could go immediately into doing deploys. I mean, again, I don't want to overcomplicate things, but I do want to tell you that you've got so many different options. You kind of have to think it through and plan it out, and think about what you want to do. So in my case here, I've got my paranoid path, and then these 3 steps are my paranoid path. So my CI process that we looked at before, code goes into source control, cool. We test it, cool, it's working. Then we deploy it. The deployment worked, yay. We got a test, we got a deployment, yay, we're good. If that is successful, we move to the next set of steps. First, I do a artifact creation. So I'll show you with the command. I create an artifact. And what do I mean by artifact? SQL script. I'm just going to create a SQL script, and it's going to capture the changes necessary to upgrade my database from one version to the next. That's it. That's all it's going to do. Nice and simple, nice and clean. Then it's going to deploy to my QA server. So I've got a deployment to my QA server. Now, normally, you would not then go on to do what I'm doing here. This is, again, I've set this up for demo purposes, so I have multiple stages and multiple steps for us to look through and see. And in this case, I've got an approval step. Now that's a manual intervention step. That is my chance to stop the process, eyeball the the PostgreSQL, the SQL that has been created by the tools, and then approve that, and then it goes to the final deployment step, which will deploy to my my simulated production server. And that's my pipeline. Now the pipeline's pretty straightforward. The pipeline's the easiest part to describe because the pipeline is just a series of steps. And yes, you can get into branching on these. You can get into multiple layers. You can definitely hook pipelines together. There's, it's an expansive system, very, very expansive. But I'm showing you just the bare bones, just the basic setup. So that's the pipeline. Let's talk about the build. Now, as I said, I've got two build steps. I've got my CI build and I've got my QA build. Now, what I want to do is, instead of looking at either of these in particular, what we're going to do is look at creating a build project. If we go in to create a build project, obviously you have to add the name, and you can call it whatever. We'll just call it demo for the moment because we're not going to save it. You have to add a source, and here I do want to show the sources. You've got a lot of choices here. The source can simply be Amazon S3 storage. It can be AWS Code Commit. It can be GitHub, Bitbucket, GitHub Enterprise. You have a lot of choices. So, we'll say that mine's, AWS Code Commit, and then it's going to look up all the different repositories I have. Right now I have one. And then you can decide, are we using branching, are we using GitHubs, or are we using particular commit IDs? We can decide all that fun stuff. We're using branching, and so we're going to go with the main branch. And there we go. And you can get in there and do some other stuff if you need to. Next up, the build is using a VM. I already mentioned this earlier. It's up in the cloud, and you shouldn't even think of it as VM. You got to think of it more as it is using processing. Right, it's set up to do processing. And so you have to determine what OS you're going to run. Now you can run Windows, Ubuntu, Linux. It depends on your tools and your tooling and methodologies. I've been doing a lot of work within Ubuntu. That's my preferred Linux. That's just the one I know better, so I use it more because I'm just more comfortable in there. You decide on the runtime. You decide on the version. You pick and choose all that stuff. You determine if you're using existing service roles or old service roles. I'm going to use an existing service role because we're not even saving this. You can then define additional VPCs and all that fun stuff, and that's virtual private cloud and determining exactly how you get access to it. And I do have a virtual private cloud. You do want to make sure that you're using the private subnets and not the public ones. Because it will cause you problems later. And then you define the security group that it's going to use, and that's how you poke holes to get in or out of your local version to your local instances, or for me to go and read up to the cloud. I'm poking holes through that. Let's go ahead and zoom back out. Obviously, you're going to control. Again, it is a VM. Think of it as processing power and not a virtual machine. But it is a virtual machine, and so you can set up the compute, how big you want it to be. I've always gone really small because the commands I'm running are really, really low level, very cheap, very simple, so I don't need a whole lot of processing power. And then you define whether or not this one's generating an artifact. Now, this one is not, another one is. And then you can define logs. Cool, all great stuff. But let's take a look at the existing one that I've built. So this is the one that we have here. Now it's run a bunch of times. It's had failures, it's had successes. Green is good, red is bad. And you can see the build history, the batch history. There's no batches. And you can see the build details, and you can see how I've set it up. So I've got the project configuration itself, the source control, which you've already seen, the environment, and again, it's the Linux environment that I'm running through, and the build spec, and whether or not there's artifacts. All exactly as we described. Now we can take a look at the build history, and we can actually open up each run that's been done, and we can see the logs. We can see all the stuff that was done. Now, I'm going to show you what I do in just a minute, but you can see that it's doing a bunch of commands. Those commands are completing, and you can see what's going on. And the most important thing that we can see is right down here. Migrating schema public with repeatable migration inventory view. So the script that we started with is what got deployed through this process. Exactly as we would have expected to see. So we're actually getting exactly what we want. It's doing all this stuff for us, and it all happened automatically in the background while I was talking to you. I didn't have to actually touch anything, move anything, push anything. It just ran. Now, how did it run? Well, that is where the buildspec.yaml file comes in. Now, there's a whole bunch of phases you can do. You can also do parameters and all kinds of other things. But you can do an install, pre-build, post-build. I'm just going to do a build. Now, you can see I've commented out various runs, but the main command that I have right now is docker run. So I'm opening up a Docker file. I'm giving it a couple of volumes, the SQL volume and the configuration volume, and those are both for the Flyway configuration. And then I'm running Flyway. So it's Flyway, and then I give it the command migrate. And that's all I have to do. The configuration file itself, it's over here, it's the Flyway configuration file. It has the connection out to the AWS RDS database where I'm running my PostgreSQL database. It has my login and my password, and yes, now you have my secret password. Feel free to hack all of my systems and my bank account. And it's got all the information I need to connect up to the databases. So that's this buildspec.yaml file. And that's all I have to do is tell it to run migrate. Now, I've got other commands I could run: clean, empty stuff out, validate checks to see if things are running well, repair, fixes things if I've messed up. And as you saw in some of my deployments, I have messed things up as I was working and testing and developing these migration scripts. But migrate does the work. So this is a single command line to start my CI process, and that's it. That's all I have to do. From there, I could start creating the automated tests. Now, I don't have any automated tests built into this yet, but I could put them into the build step. I could add another step within the pipeline. Again, you'll work out the details on exactly how you want to configure things, but you get the idea. Now, I've got a second buildspec.yaml file, but it's not called buildspec.yaml. It's called QA build. Now, that's my second build. Remember, we talked about the fact that I had another build that runs. Let's go back to the pipeline and we'll show it to you real quick. Right. Oh, we're in edit still. Hang on. Let's hit cancel. And discard the changes. Cool. So this step, where we create an artifact and run the QA deployment, that is controlled through an additional configuration file. And I'll tell you why. Because in this configuration file, I am passing in some new things. Yes, I'm calling docker run. So let's just look at the first command. Docker run, Flyway, and then I'm making some changes. I'm changing the URL to a different database on RDS. So I'm now running it against the QA database on RDS, or the QA database server, and I'm giving it the command dry run output and passing it off to S3. And so what it's doing is it's spitting out a SQL statement. So it's putting out the output.SQL statement, and that is going to be used later. We'll get to it in a minute. Then I run another command. The other command does pass in the same database again, right? So changes the database in the configuration file on the fly, and then it runs the migrate normally without having the dry run output. So that's how we can create the SQL that we need later and do a deployment to my QA server, all within a single step, just a couple of commands. So it's all about learning those command lines, putting them in the right order, and then off you go. It's really not hard. there's just a lot of little bitty things to learn. So you got to put all that stuff together, and then you'll be able to start using it. Now, the next thing we have to talk about, we've talked about code commit, we've talked about code pipeline, we've taken a look at code build, we've seen the output from code build, we've seen the input from code build. The next thing we have to talk about is code deploy. Now, right now, no deployments. I have set up one application. We have not yet deployed to it. This application is my Ham Shack radio database. It is using Lambda, which is just another computing mechanism. And what this will do is it's a really simple command. All this does is picks up the SQL file from the S3 storage and deploys it to my production database. But it will only do it after we approve through the manual approval process that I set up in my pipeline down here, where it's still waiting for me. Still going like, hang on, what's going on? Well, let's go ahead and we can review. We can open this up, take a look. We can get in there and take a look at the SQL file. I'm not going to do that right now. It doesn't matter that much. And then when I hit approve, it'll go on through the rest of the process. But that's it. So you've seen all of the various stuff, starting from here where we created a SQL file. We put it into source control. We passed it to the cloud. The cloud took it. The pipeline took it and started doing its run, and then everything else took it from there and completed the process. And so that's it in a nutshell. I mean, that's how it all works. That's how it all ties together. The key here is the tying together process. So that's why, while you're going to spend time, you're going to spend very much time learning how to get the commands together to do the stuff you need to do. Yes, that's going to be a fundamental thing that you're going to have to learn. Regardless of which of the data tools you use, you're going to have to learn to mess with that. Again, I'm using Flyway, and these are Docker commands through what are Bash scripts. Fine, there's other ways to do it, but the same idea is going to run no matter what you do. This one is straightforward and simple. Other ones may be more complex. But the whole idea here is you're going to have to do some coding in here. The real key, though, is that you then can tie it all back together over here. Now, interestingly enough, all of this can be coded as well. AWS has got a whole methodology for capturing these things and turning them into code, and then using the code to manipulate these or recreate them. Or I could spit it all out to code and hand it to other people, and you guys could use this. I would not take this. This is very much a simplistic, core, basic, CI process. And frankly, rather than take my really simplistic code and copy it so you guys can do a CI process, go learn how to do a CI process. You will get more out of it than taking this bit of code, which is not complex. I mean, as you can see from here, I'm not doing anything complex. I'm keeping it as simple as possible, in fact. My CI process right now is one command, right? I mean, really two. Docker run and then Flyway migrate. That is the two commands that I am running. And, and I'm, again, all in one line, keeping it as simple as possible. That's my goal, was so that I can explain all of these moving parts without having to have lots and lots and lots of complexity on top of it. So this is very simplistic on purpose. That is pretty much the demo. So we're going to go back to our slides and do a recap of all the little details that you just saw. Now, hopefully that was useful. And let's talk about what happened. Now, we're completely coming at it from a PostgreSQL database. So all our code is in PostgreSQL. And whatever changes we're going to make, it's all SQL focused through Postgres, and so that's great. We've generated that script. You saw us generate the script. You were there. You helped me write it. So we've got one script. Put that together. We're using Azure Data Studio to write the script. Nothing tricky, nothing special, but I just want to let you know what tools we were using. That then was checked into a local Git repository, something running on my laptop for storing versions of code. Cool, that's great. We did a push. The push put it up to code commit in AWS. Okay, no problems so far. I mean, it's fairly complicated, but it's not crazy. We generated a SQL script using Azure Data Studio. Azure Data Studio allowed us to add it to Git in source control. We then did a push up to code commit. Now, code commit, once that's done, once the push succeeds, that fired the trigger that we saw inside of our pipeline. And so the pipeline is going to start to do things. Now, the first thing the pipeline did was run the YAML file that we looked at in Visual Studio Code. That's the reason I put up the Visual Studio Code, is because that's what I was using to edit my YAML file. And the YAML file is running it inside of code build. So code build is consuming the YAML file that we created, and it's firing off based on the pipeline triggers from the Azure pipeline. Yes. See, when I told you that this is not, it's not hard and it's not really complex, but there are a lot of moving parts. Next, we fired up a Docker container. Cool, right? The Docker container had Flyway on it, and that's going to run its processes. Excellent. So we know what's happening there. And Flyway ran. Cool. So Flyway ran. And then next up, after Flyway ran, we were able to use, again, pipeline to control the processing, and we generated an artifact and then deploy, consume the artifact to then generate the scripts and code out to our simulated production environment. And so that's everything that occurred. And yes, there's a lot of steps here, but each step is not very complex. And so many of the steps are encompassed in a single line of code. But you want to break it down so you understand what's going on when you start to set up these types of processes. And then finally, of course, we did land at the Postgres database. Now, some additional reading. There's a lot of stuff going on, a lot of things we're talking about here, but AWS published a little over a year ago a guide on how to do continuous delivery, a continuous delivery pipeline inside of databases. And it's a really good document on AWS. It's very, very useful. So I would recommend you read that. Also, I would recommend that you read the Phoenix Project. If your company is looking or thinking about moving into DevOps, if you just want to champion DevOps within your organization, get all of your coworkers to read the Phoenix Project. It's a novel, but it's a novel about IT. It's not a great novel, but it's a fantastic parable of the concepts of DevOps, why we need a style of development that's like DevOps, and the rewards of moving to a DevOps style approach. I would also recommend the Introduction to Database DevOps by Robert Sheldon, and finally the Flyway documentation to go over some of the stuff that we did today if you want to get into that in more detail. Now, if you want to get started with this, I want to walk you through the basics, just enough. We did a little bit of stuff today that was more than the basics. We went beyond it, not way far, but a little bit. So first up, get your database into source control. Now that means you're going to have to go and pick one of those database management tools. You're going to have to figure out which tool is going to work best for you in your environment. Maybe that's a SQL Server only. Maybe it's a multi-platform. You'll make those determinations yourself. You're going to have to decide if you're looking at state-based or if you're looking at a migrations approach, or a hybrid, if you can get a hybrid approach. Cool, right? You've got to make those calls, but that's where I would start. Start with the ability to move in and out of the database. Get that done. Cool, win. Now, get your command line skills up. Get it so you can write PowerShell scripts or Bash scripts or whatever. Whatever it is you need to do to manage this stuff from the command line. GUIs, I like GUIs. I use GUIs all the time myself. The demos today were mostly inside of GUIs, but the work is done by the command line. The work is done by code. So you need to get that command line skill set up. Next, build a CI process, continuous integration. The first two steps that we showed today inside of our pipeline, source control and a build, that is CI. And that's all you need to start. Do that. Get that working consistently. Get that working well. Then, once you've got that down, you're going to be able to expand it. But you've got to do that much first. Don't try, we're going to build this and build that. We're going to automate it out to production. You'll fail. Start simple, start small, one project, one goal. Automated through CI. And then expand. Just get that CI process done. Get your stuff into source control, get the command line, get the CI process. Then you can grow. Hopefully that covers everything that we need. You guys can get going in AWS. We've seen the demos, we've seen the code, you've seen the stuff going on. And I hope you're enjoying the Data Platform Summit, and I'm answering all your questions down there in the Q&A window. Special thanks to Microsoft for supporting SQL Server Geeks and the Data Platform Geeks and the whole community. They do great stuff. I'm talking about Data Platform Geeks. I like Microsoft too, but the Data Platform Geeks, great group of people. They're doing some fun stuff. You guys are doing, you're seeing the benefits of it by attending this event. So please get in there and support them. Remember that you've got chances to win prizes, so make sure that you follow us out and win a prize. And hopefully you enjoyed my session today and you had my contact information. Please use it, get in touch, and let me know if I can help. My name's Grant Fritchey. I work for Redgate Software. Thanks for watching.